Okay, welcome to today's talk about automated testing strategies for microservice architectures. My name is Flo. I'm working for 2 years at Spotify. Before that, I was 9 years at IBM. I have a girlfriend and yet no kids. So let's talk about today's agenda. I'm going to talk about why testing, so why should we test? I'm going to talk about general testing approaches, like the high-level testing approaches. Afterwards, I'm going to talk in depth about integrated testing strategies, about additional safety nets that we should all comply on, and in the end, there will be a quick summary, and then there's time for QA. A little bit about a glossary. If I'm going to talk about device or speaker, this is from, you can see this as a client. This is because I'm so used to talk about devices and speakers, as this is what I'm building the backend for at Spotify. If I'm going to talk about a middleware, then I mean a traffic interceptor within a service. That means something where you pass on your request and it decides, should I already answer this or not? Or should I pass it on? And if I'm talking about mocking, then I'm talking about everything that is not real code or that is not a real service. So let's start. Why testing? So in our day-to-day work, we want to move fast and with confidence. It is all about all the continuous delivery and everything is all that we can release software way faster than our competitors. That we are quicker in releasing, and thus we gain a competitive advantage because we can release software faster. Therefore, tests should give us confidence. They should be fast, accurate, reliable, predictable. And therefore, they should give us a way to do an easier maintenance. Meaning, if I'm working on a change and I make that, the tests should give me all the four attributes that I just named, which is fast, accurate, reliable, and predictable. In order for me to really be confident that I can change now. And yes. So therefore, what we want to handle with testing is we want to find failures at an infrastructure level, like network failures, or specifically there, how our service behaves, how our code behaves if something like this occurs. We want to also catch faults at application level, like uncalled exceptions or panics. And yeah, that's why we should test. Further, we want to find we want to test in order to just catch bugs. I mean, everyone who codes creates bugs. I do that every day. And therefore, tests help me to find those bugs. So now we're going to talk about the general testing approaches. Who has ever seen this? Probably most of the people. Oh yeah, that's most of the people. This is the classic testing approach. What the goal here is that we have thousands of unit tests, we have hundreds of integration tests, and we have tens of E2E tests. This, in my opinion, has changed throughout the years to something more like this, which is the so-called microservice testing honeycomb. There, we still, and don't get me wrong there, we still focus a lot on unit tests, but we really need to think of what we test here. Then what we stress out in the honeycomb is the integration part, the integration testing part, and the E2E tests now become not end-to-end tests anymore because we don't test a monolith. We test integrated, meaning we test how does our service behave in our architecture. And yeah, the tests should always be run. When you create a PR, in order to understand, okay, is what I'm gonna merge, is that what I'm about to merge, is that safe? And post-merge, in order to understand, okay, were there some conflicts, was there anything that changed, and straight before releasing. An important note is also that the integrated tests, they should always test exactly what you release. Meaning, if you, for example, have a Docker container, then test the Docker container. Don't start your service somehow else. Really test what you're going to release. Okay, then let's talk about what the single stages, what the different stages of the tests should cover. And therefore, I'm going to use the terminology of the honeycomb. So, what should unit tests cover? In my opinion, they should only cover the low-level algorithms. They should not test an end-to-end logic. And therefore, what they exactly do is they test like for loops, they test if-else, they test, does the calculation that I'm supposed to do at the moment, does it do what it should do? So how should they be written? You should always focus with unit tests to only test one unit at a time. Given, for example, Java, you should only test that one class. That means, that is easy said, but what it actually means is you should not have really static dependencies in there. You should try to avoid static, because then you can mock that. If you don't do this, your test will end up like this much of mocking before you call, and this much of verifying after you call your test method, and this much in between that you actually test. I've seen that tons of times, and yeah, it's not really maintainable. So what you also want to do here is, as I just said, you pass in the dependencies in the constructor, for example, of the class, and then you use mocking frameworks. I think every language has theirs. For example, in Java, you could use something like Mockito, which I'm a big fan of. And what you also want to do on a unit test level, for example, is what is currently a bit hyped, is the property-based testing. So as you test your low-level algorithms, you want to test it with a lot of different properties, with a lot of different inputs. So let's move on to the integration tests. Integration tests, which is the ones that we are really stressed out on in microservices, is you test multiple units together, meaning you test like a class of your API layer, meaning given you have an API method or an API, you take the logic class of that API method and you test that up until down till the database. Your database might still be mocked. You can use like an in-memory database or whatever fits you. There are also testing containers. But you really want to test multiple units together. I mean, probably everyone has seen these funny GIFs where you see 2 unit tests and no integration test. Yeah, I didn't want to put them there, but I think everyone has seen them. So, and we don't want to end up there. So how should you write them? You mock the dependencies, you mock databases, more or less, and see your service as a black box. Really, just try to understand what your dependencies sees and test that. but all in a really controlled way and in a fast way, which is like in the mocked way. And then we move on to the integrated tests. And this is where it's getting complicated. This is where it's getting flaky. This is where most people have a lot of problems. And in my opinion, this is the Holy Grail of microservice architectures, to do that right. And I think there's not yet really the really best fit. So today we're going to talk about a lot of different strategies. Or there are a lot of different strategies, and I take insights or give you insights about a view which I usually worked with and which I think they can work quite well. And as I mentioned before, with integrated tests, we really test how does our service behave in our environment. We want to find out what our service does, how does it behave, can we take down other services? Yes. So, as a general thought first, what you always need to think about first is, what kind of service do I have? Do I have like a fake pipeline? I mean, I don't know if you have been there, but sometimes you end up in a situation where big data technologies would be a really great fit, but you don't yet have big data. So it's probably not needed that you need something like a Hadoop cluster, which I call a fake pipeline then. Then you need to think about how many dependencies do I have. These fake pipelines usually have maybe one, maybe two dependencies, which are just bringing in like small inputs. Or do I have a service which is like a really centered service where I have like up to 20 dependencies maybe? Then you need to think about how much of the traffic that I gonna test with should be mocked, and how much do I want to use real traffic? And yeah, these are the questions that you ask yourself before you decide on, and then you're gonna decide between one of the following dependencies. The first one is the mocking strategy, which is, as you can see, you have here we have three dependencies. You have your service, which is under test, which is the yellow box here, and you have your test. And here, everything is going to be fully mocked, meaning every dependency, you mock it away. The downside of this strategy is you can't really use real clients here. You can only call your APIs. Only your service will be here. There's no real dependency because everything's mocked. And therefore, they are quite fast, because a call here might take 2 milliseconds, but usually when you call a service in production, they usually don't respond within 2 milliseconds, or it depends on their nature, but given most dependencies I've seen don't usually respond within 2 milliseconds. That makes those tests really fast, but they are not really accurate. So the moment you're going to release that, maybe this dependency has changed, and then you're screwed, because your mock code is not up to date. So let's talk about another strategy. I call it the input-output strategy. This works best for fake pipelines. I've written those fake pipelines, and there they really work best. You should use your service again should have a really low amount of dependencies, maybe 1 or 2, as mentioned before, and you can't again use real clients, but honestly, there shouldn't be any clients if it's like a fake pipeline. what you do is you're going to have a recorded input-output. You record that from your production days, and you have, it's important that output one time, you need to review it. Is it correct? Otherwise, this doesn't really work out. So you're gonna check, is that output correct? For example, where we've used this a lot was in our accounting system. We've used one day's report, and we checked together with finance one time, is it fine like this? And they said, yes, that is exactly what we want. And then we recorded this based on that input. So what you do is, you're gonna send that input to your service, and your service will create a second version of this output. And what you just then need to do is, you need to compare those two versions. So, and that is everything that there is. The good thing is, those tests are really fast, because you don't call any dependencies, you just test, they are as fast as your service, basically. Okay, let's talk about another hyped topic at the moment, which is contract-based testing. A lot of people ask me, like, yeah, but this is like the mocking. It is not really. You still, what you do is, you don't write the mocks on your own, you generate them. And this is also the biggest downside of this. If you don't generate the contracts in a regular way, meaning whenever someone releases, whenever someone changes something, you will be screwed here. Because then you basically have your mocking strategy again with all its downsides. You can't use real clients here, but in this scenario, it shouldn't matter that much, as you also generate your contracts and others test against your contracts again. So, really, the real downside here is if you don't generate it. And this is, for us, for example, this is why we don't use it, because there's no clean way how we can generate all the contracts from our API layers, and how we can make sure that not just if the API changes, but also if, like, the message, if you have behavior changes, how that will affect your service or your contracts. So now we come to one which is really controversial discussed, but I love it. It is, I call it the redirect production traffic strategy. The good thing is, you don't want to use mocks, or you don't want to use mocks, or your upstreams change very often. You can use real clients here. You use your full production environment. This is your service in production. This is not your service under test. In your data center with all its dependencies in the data center. So what you do is you take your real production environment, like this is my prod, and I set up my testing and my service, for example, on my Jenkins environment. Maybe that runs on one server in my data center, but basically I set this up. Then what I do is I have here a traffic interceptor, and I have a redirection utility. So this traffic interceptor opens up a WebSocket, and the redirection utility hooks them up. So your test just starts and sends a message to your production service via your reverse proxy, whatever you have there. You use a real testing user, and this service now knows I should redirect all traffic for test user 1 to this service in the traffic interceptor. And this is when it redirects it, your local service will generate the output and send it back to your test. What the cool thing is here, you can use your real clients. There's no way, there's no need to mock anything as you use your real productions. So the downside here is it is flaky. But I usually give the counter argument that it is only as flaky as your production. Meaning, if your test is flaky, something in your production is flaky, and that means that your customers get a flaky experience, which is not what we want. So we better make our tests stable. And that, of course, means if I have in my clients, if I have a retry logic of 3 or 4 retries, whatever I choose here, then my test is allowed to have that as well, to have like these retries. As I really try to be as close to production as possible. The good part here is, the moment I release it, I've tested with all my production dependencies. This service called them. That means I really know that the things work. At least what I test. So let's talk about other things that you should really take care of and that you should think about. Because testing is not everything. The moment you're going to release, you better release first on something like a canary release, where you check the behavior, because let's be honest, we can spend days and days and days in writing tests, but in the end, we're going to release and we missed one single case and everything breaks. That happened quite often to me. So the good thing, the thing you need to take care of here is deploy to a canary, analyze it for 20 minutes, depending on how much traffic you have. Our systems usually have quite a high traffic, like, I don't know, 100,000 requests a second or so. So you pretty fast notice if something is broken. And that means you will see it on your canary quite fast. Another thing to take care of is the moment you roll it out and another service breaks, you need to make sure that your service behaves in a way you want it to behave. And that I usually call it being a good citizen in a nice neighborhood. So that means you can take one example. Take your example, your database is slow. You have 100,000 requests a second. I don't know, 10, 15, 20% of the requests will time out, or your clients will retry. What you're going to see is a huge increase in requests, and in that moment, your database decides to be fast again. If you're not careful, you will do an internal DDoS attack on all your downstream services, on all your dependencies, which is what we really want to avoid. And this is why we use circuit breakers and why we use exponential backoffs and why we really want to tune our request queues. Another good way of doing being a good citizen means also I do chaos engineering. Who has heard of chaos engineering? Okay, not too many. So what you basically do is you decide, like, 2 people, like we call it at Spotify, we call it DIRT, which is disaster incident response test. So 1 or 2 people of a team are involved, and they know what the team hurt. What would hurt if I would do that in your production environment? Your team knows that, and therefore you're going to do exactly that. Meaning you have problems with Cassandra. If there are nodes down, then shut a node down. You have problems if an upstream goes away, then shut one upstream down, and see how your system behaves. Can I maybe have a default response? For example, if you serve music and you decide what to play next, and the next thing would be an ad, can I maybe just skip the ad and play music instead? So really plan for failure here. And then there's one thing that we now completely missed. Who could guess it? It's security. So what can I do in order to be secure? Like now I've built this amazing microservice backend. I have more than 1,000 microservices. Everything works. Everything is friendly. But I'm not really sure if it's secure. So what you do there also is automation. You need to automate as much as possible. That means you do automated static code analysis in your pipelines, pre, post merge. You do automated black box scanning. Like we have if we are there, we all have these pipelines now, which are nice and run fast and everything. And then let's just spin up as part of our pipeline once a week a container that fires home that fires on our production service and checks what does it respond with. Does it respond with a 400 in case I would expect a 400? Does it respond with a 500 instead? And then another good thing where we made a lot of, or where we gained a lot from was create threat models for your services. There are different strategies for creating threat model. I usually like just think about your business logic. What would you, as an attacker, want to gain from your system? For example, if you think about the Spotify Connect systems, where you can remote control your devices, the immediate threat that comes to my mind when you think about this is, I want to control every person's speakers, every person's devices, and play, I don't know, Lady Gaga or something. Yes. So let's wrap it up with a summary about our strategies again. We have, as we said, we have the mocking strategy, the input-output strategy, contract-based testing, and redirect production traffic. We have, by number of dependencies, the mocking strategy usually only works up to a medium amount, let's say 3 to 5, because you have to main that code. You have to understand. You have to always check how often does your upstream change. Input-output strategy, in my opinion, only works for low to up until medium, for the same reasons. Contract-based testings, if you follow what I said and you really generate all your clients, you generate your contracts, then it doesn't matter. The same is for the redirect production traffic, because all your dependencies you won't need to care about mocking or anything, because you know you use the production ones. Then let's talk about the flakiness. The first two are not really flaky, but they might not be accurate. The third one might not be flaky, but if you don't generate, it will be flaky again, or it will not be accurate again. And then if you don't generate them, you basically have the mocking strategy. And the last one is only as flaky as your production, which might sometimes be a problem. So what about the risk of releasing? You have a high risk here, because you never know, did my dependencies change? You have a low dependency here, because in the input, a low risk, because usually the kind of dependencies that you have there is of a nature that they provide you some data, and mocking that usually doesn't give you a high risk. Contract-based testing is low if generated. If not generated, you get too high. And the redirect production traffic is, in my opinion, the lowest, because there you actually tested what was, or you actually release what was just tested against your production dependencies. And now let's go again over the downsides. This is not reflecting production, the mocking strategy. You have, for input-output strategy, you have the static recorded output. That means there are two problems with that. One is you have to be sure that your recorded traffic is correct. And the second one is, if your output changes often, you always have to update all your test outputs. So where we use this was in the accounting world, as mentioned, and these accounting reports, they usually don't change that often. They change maybe once a month. And therefore, we could easily, or once every 2 months, and therefore we could easily use this. For contract-based testing, the downside is the contracts need to be generated. You need to be sure that your behavior, that you also test the behavior here. And for the redirect production traffic, the downside is the flakiness. Yes. So that's it. Now we have time for Q&A. Are there any questions?
Hello, thank you for your talk. About the integrated testing, I have a question. What kind of tools do you use at Spotify? Do you use something like Selenium or Cypress or yeah?
So what I had before the situation in another company. As I said, I worked before at IBM, where we had this insane Selenium framework. But we tested there wrong things also for our services. At Spotify, like my backend is the backend for the speakers, and there we then really use the real ESDKs. For the tests to be written in, we use usually JUnit. We write JUnit tests, but those start up the ESDK speaker, and then yes. Did that answer your question?
Yes, thank you.
Okay, thanks. Yeah, but I'm sure there are teams, by the way, who use Selenium and who use, who test their stuff with it.
Hello, here. Hi.
Yeah.
Hello, here. Hello.
Hi.
I have a question about how many of these test users you have in your full system, and how many fake traffic do you generate when every single service does this production testing strategy?
Yes, so how many fake users do we have? I think our team, and we have hundreds of teams, our team has like 50 of those test users, I think. I'm not sure that everyone within Spotify does that. As you might know, we work completely autonomous in the teams, so you don't really know who does their testing how. But I know for the teams in my department, we use that a lot. We maybe have 100, 200 test users. And yes, how much fake traffic do they generate? I don't know. It's not noticeable.
But all right, that would have been the follow-up question.
That also is
fuck up your numbers then.
Yeah, numbers. Let's make something up. I mean, we have 200 users, and we have 80 million paid subscribers, and we have, I don't know, 160, 170 million users in general. So those 200 are not really noticeable. That is
times the number of teams then.
Times the number of teams. But I mean, in our department, we have these maybe 150, 200 test users. So our team has 50 test users. But what you really wanna check on is more how many tests do I run at the same time? So let's say I run 10 tests in parallel. That means 10 users at one given point in time. So that doesn't really create that much traffic for us. Yes?
if you redirected production traffic, how do you deal with data? How do you what data do you use when you make production testing? Because you have to have a use case, and it needs data to fulfill its test.
Yes. So this is a good question. What data do we use? What we do is we test it end to end. That means we take a speaker, we simulate that it now comes online, and that now someone says something like, Alexa, play something on Spotify. And then it should behave. It should do what it needs to do. So we really test with real clients then. And that means they're end to end, meaning from device registration or from client registration up until deregistration.
Yes, but that has data dependency. If you say, please play something, this depends on the data you have in another service, perhaps.
You mean what tracks we then use? Like we have some samples of testing tracks that we use.
Yeah.
Someone defined them, and then I don't know, let's say AC/DC or yeah. But we basically we use just tracks and then we play them. Yeah.
Okay.
Hello.
Yeah.
Maybe you said it and I missed it, but do you do stress tests, and how do you do them, and where would you place them in this honeycomb?
I would do the stress test as part of a black box testing. Usually we get stress tests every day, every second, but we once we want to release a new service, we want to see how it behaves, and there we just we have several tools. We have a homegrown tool for stress testing, and we use JMeter sometimes, and then we spin up a container and we fire against it. So the thing is, once you released it and you have this amount of users, you don't really need to do a stress test. You only need to try to calculate, okay, how much more can I take? What growth can I support?
All right, thanks.
Up here in the middle. I was wondering whether you do hallway testing. I can imagine that would work pretty well for you.
What?
Hallway testing?
Paul?
Hallway.
Hallway testing?
Yeah.
What is this?
You basically ask a bunch of colleagues to test your stuff.
Yeah, this is what we do as well. Like, yeah, we have an employee build of our app, and you basically every employee gets a nightly version of the Spotify app, which is sometimes quite crappy. Like you then yeah, it is broken then, or some features don't work. But you get the new stuff out to 4,000 people, and then yes. And then of course you do rollouts. You do slow rollouts, like you do the A/B testing. You do slow rollouts. That means when we in the backend release a new feature, we usually start with 0.5% of the traffic. Then we move on to maybe 5 or 10%. Then we check how does the system behave. Can it handle more? And then after a while, we're gonna go to 100%. So we really do these calculations like every day.
Okay. Hello? Okay.
Yeah.
Yes, here.
Yeah.
Yeah, well, kind of answer already my questions. But do you have also like a separate QA team as well? Or is everyone testing everything?
We don't have a separate QA team. We do everything each team. Like the team owns their service end to end. That means they own the architecture of it. They own the production machines of it. They log on to the production machine if something is broken. They own basically the whole services end to end, and therefore they also own the testing. So with the autonomous teams, you can try to align, which is what we really try to do, and quite often succeed in, which is basically you try to align the way how a service is written. What frameworks do I use? So yes, and then what we also do is we have like one team which is taking, which is running periodic tests against the production in order to see, okay, does it still behave as we would expect it? But those are not QAs; those are SREs, like site reliability engineers.
Yeah. Thank you.
Hi, up here.
Yeah.
You talked about the redirect reduction traffic strategy, and you said you have some kind of interceptor. Do you modify the source code, the production code, in order to redirect the test users? Or do you have something on top so that you don't need to modify the real source code?
We have that running in the real source code, which is that one interceptor. But I think this is going to be really great in the future when you're going to use when you have systems like Istio and Envoy. I don't know who has heard of this. Everyone? No. So what you basically have is you have a little service next to your real service, which every traffic goes in via this little tool, and every outbound traffic goes out via this little tool. And you can do amazing things there, like distributed request tracing, because every request has to pass this. You can do all the resiliency patterns that I just mentioned. You can do in there, and you can do the redirect also in there. So this is going to be a bit nicer once this is more becoming a thing.
Okay, thank you very much.
Hi.
Hi.
You up here. You said that you are sending all the data to the production. So basically, do you have some kind of leftovers there after every test? Because you're creating some test data, and they probably stay in the environment, in your live production environment. Do you clean it up somehow? How do you detect this data? Does this data can this data probably maybe affect actual users of the application?
So usually, single users should not be able to affect the whole bunch of other users. We leave the data there, but if you think about it, what you could do, you could have a separate database cluster, for example, for your service in test. And that one is then, it is not then as close to your production as possible, but there you would avoid things like that. But we don't do that. We use the production there, and yeah, we don't store data that long though in our service layer, and then. If you go more downstreams, the events that you generate that end up in a data lake, there you can run cleanup pipelines that are targeting those users.
Okay, thank you.
If you don't want like the 10, like I don't know, the 50 users affecting your consumption metrics or whatever your metrics you have. Are there more questions? This one. Okay.
I have one question about the nightly version you just mentioned, and that you add your features there first before you bring them to the public. How long does it normally take from a feature from the nightly internal version to become public?
But I think it strongly depends on the feature. I'm not doing client development though, so I can't really tell. Sometimes it takes months, sometimes it takes 6, 7 or month or nearly a year. Yeah, but sometimes it's quite quick.
Okay, thank you.
It really depends on the feature. Okay, there's one more. No. Okay, that's it then. Thanks for coming by. And if you have further questions, just hit me up and ask me stuff.